Right, this is Algebra 2, 623. Today we're going to be talking about writing equations of exponential functions today. So our big thing that we're looking at today is this story problem. So this goes down to how they predict due dates for women that are pregnant. So when a woman becomes pregnant, so after the embryo is implanted into the womb, the body starts to release this hormone called HCG, and it goes up more and more and more all throughout her pregnancy. And that is what tells her body to um, take care of the baby and how to regulate and all that kind of stuff. So how they predict when the woman's due date is they just go off of when the embryo was implanted into the womb. So in order to figure that out, they look at what these HCG levels are. So they'll get two readings and then use those two readings to kind of find the quote unquote start point. Because that is going to be when the hormones go from their normal level and start to go up and up and up to the very, very high levels they end up at. So that's effectively the premise here. So they're giving us 2 points. They're saying that, hey, on March 21st, it was her first visit to the doctor, and he measured her HCG level and got 200. The unit is milli international units per milliliter. It's a bit of a mouthful, so we're just going to say it's 200 units. Right? So it was 200 units, and then 2 days later they do a second test, and they get 392. So why do they have to do 2 tests there? Because everybody's body works a little bit differently. So while 200 might be normal for one person at this certain day, for a different woman it might be 180, it might be 300. It's all different levels. So they need to get 2 different points so that they can figure out, well, what rate is this woman's body producing the hormone at, and then they can make that prediction earlier based off of that. So we have our 2 points, or the first on March 21st being 200 units, and then the second one 2 days later being March 23rd, and that is 392 units. So we're going to go through the process, and I'll kind of walk us through it. So let me change this over so we can see what I'm writing down. So I can define my time zero as whatever I want. Later on, the book is going to define March 1st as day 1, so it would be February 28th as day 0. We're going to call March 21st day 0 because, as we've talked about in the past, having that initial day be 0 or a initial time be 0 makes your calculations crazy easy. And you can define it however you want, so you might as well define it in a way that's going to make it easy for you. So my 2 points that I know, I'm going to first say that March 21st equals t being 0. Okay, so that's just so that I keep that in mind, so that when I get my final answer, I know what it means in this context. So my 2 points are 0 being my time, or my x value in this case, and then I have 200 units of the hormone. Then my second point is on day 2, if this is 0, because it's 2 days later, I have 392 units of that hormone. So I know that the hormone grows in an exponential pattern. So the pattern for our exponential models is y equals a times b raised to the x power. Right? And a and b change depending on the problem. X is your input, y is your output. So in our case here, x is our input, that's our days, y is our output, that's our amount of hormone. So I can plug in these points and I can make a system out of it because I have 2 variables, a and b, so I need 2 points in order to find both a and b. Now, the 0 makes it really, really easy, but if I didn't have the 0, I still could solve it. I probably just want to use substitution, though. So I'm going to use this 0, 200 points. So plug in 200 for y, and I'm going to plug in 0 for x. Well, b raised to the 0 power, that's just a 1. So a times 1 is a, so then that's just A is 200, I'm done, right? So there's one of my variables. I found A. Now I still haven't found B yet. It's going to be very easy for me to find B because I know what A is, and I can just use this other point. I can't use the same point A again because it wouldn't really help, but I can use this one. So if I do that, 392 is equal to A is now 200 times B raised to the 2 power. So now I just got to solve for that B. So I'm going to divide by 200. So I'm going to take 392, divide it by 200, and then I get B squared equals 1.96. I'm then going to square root that. And I get B is 1.4. Now I don't need the plus or minus because I don't care about a negative option because I can't have a negative growth rate for the hormone here. So that's why I don't care about the negative option. So my equation then would be y equals 200 times 1.4 raised to the x. So that is going to be what models the amount of hormone in this woman's body on day X, X being the number of days after March 21st, and Y is the A amount of hormone in her body. So if we hop back over to this, it says that for most women, their base level, and this woman's base level as well, is 5 units. So once we find when this graph was at 5 units, that is going to be the day that the embryo was implanted into the womb. So that's what we're looking for. So if I go back to my equation here, I'm looking for when is y 5. So I'll plug that in. 5 equals 200 times 1.4 raised to the x power. Okay. So now I have to get this 1.4 raised to the x by itself before I can do that log trick. So I'm going to divide by 200. So 5 divided by 200, I get 0.025 equals 1.4 raised to the x. They'll take a log of both sides. Log of 0.025 equals the log of 1.4 to the x. Now I can do that property about bringing the x out front. The log of 0.025 equals x times the log of 1.4. Divide both sides by that log of 1.4. And I get the log of 0.025 divided by the log of 1.4. And I get x is negative 10.96339921, etc. Right? So context of the situation, that matters here. So x is number of days, right? If I say, hey, it's 10.96 days, we're just going to call that 11 days, right? So negative 11 days, meaning that the implantation likely happened 11 days prior to March 21st, aka March 10. Right? And then the final question which we kind of get asked here is, well, if the approximate time after implantation is 37 weeks, gestation is 40 weeks because it's typically 2 to 3 weeks from the fertilization to the implantation. So that's the kind of missing 2 or 3 weeks there, in case you were kind of curious. So if I do 37 weeks past this, we actually end up November 24th. And that's our due date. So there we go. So that's how we can make a prediction for due dates. Now there's other ways that are less accurate than this. A lot of it is just kind of based off of counting when they think it is, and so it's kind of a pretty wide window. But if they actually do the blood test to determine if they're pregnant, this is typically how they get that much more accurate due date out of it. So there's your little FYI about due dates from me. So anywho, all I want you to do is go ahead and try problem 125 out. So this is going to take that same context, but change it up just a little bit. So it's the same type of problem. Try it out and see what you can do, then come back here. Okay, so now that you're back, get some clean paper. We're going to do 125. So the points that we're given are the point 3, 12.5, and the point 4, 11.25. So we know that this is a decreasing model because I'm going from higher to lower as I go further right. So that's the first part there. Now I also know that I have a horizontal asymptote at 10. So graphically, here's my horizontal asymptote. I'm going to be doing something like that and then following it as I go further and further right. Okay, so the equation that I know is y equals a times b raised to the x. We're going to add one more thing to it, that plus c. Now that c is how far up I've shifted my graph. Well, I've shifted this exponential graph up 10, so I know what c is just from that context. So y equals a times b raised to the x plus 10. At this point, it's the same thing we just did, but now there's a plus 10 on it where there wasn't prior. So let's take a gander at doing that. I'm going to rewrite my points 3, 12.5, and 4, 11.25. Sorry. All right, so if I plug the first point in, I will get 12.5 equals a times b raised to the x plus 10. So I can subtract over 10, and I get 2.5 equals a times b raised to the x. Well, now I also want to do that for my other point. So I'll get 11.25 equals a times b raised to the x plus 10. Subtract over the 10, and I get 1.25 equals a times b to the x. So I have two equations and two variables, so I can solve this system. Now, I can't solve it like I've solved ones in the past where I can just kind of cancel things out because it's not written in that form. So I'm going to want to do a substitution. So what I'm going to do, I'm going to take this and I'm going to divide it over and get 2.5 over b to the x equals my a. Right? I just realized that I forgot to plug in the x value, so this is a 3. And this one over here is a 4. Wondering why I was missing, I had one extra variable there. Okay, so there we go. My bad there. All right, so now I have a. I can plug that in for the a over here. So I get 1.25 equals 2.5 over b to the third times b to the fourth. So over here, these are just going to cancel out. If you use 3 b's in 3 of those 4, so it's just 1 b left over. So I get 1.25 equals 2.5 b. So I can just grab my calculator and go 1.25 divided by 2.5, and I get half. Right, so there's my b value. Now that I have b, I can fairly easily find a. I can just plug it in here because it's already kind of solved for. So a would be equal to 2.5 over 0.5 to the third power. So if I do 2.5 divided by 0.5 to the third, I end up getting that my a equals 20. Okay. So then my equation would be y equals 20 times 1/2, which is my b, raised to the x with a plus 10 on the end of it. So there would be my equation, which would model that situation. All right, so with that, that is going to be it for us here. So I will go ahead and give you guys the homework. We are looking at problems 127 through 136, and I will talk to you guys next time.